Today's lesson is going to be about some calculations that we actually reviewed during our review session. When we did our first unit. So hopefully some of this will sound familiar to you. Let's start with percents. First of all, if you're doing any kind of percent, doesn't even matter what you're taking the percent of, try to remember that it's going to be a part over a whole times 100. Part over a whole times 100. In chemistry, we usually talk about percent composition in terms of mass. So for example, if I said hydrogen peroxide, a lot of people would look at that and say, oh, it's 50% oxygen, it's 50% hydrogen. And that's true in terms of the atom, but in terms of the mass of it, oxygen weighs 16 times more per mole than hydrogen. And so it's going to be the percentage of oxygen by mass will be a whole lot more. So here's how you calculate the percent composition of a compound. On the part, the top of the fraction, you're going to have one element. So in this case, let's just start with hydrogen. The molar mass of hydrogen is about 1 gram per mole. I'm just going to round it. And we have 2 of them in the formula, so don't forget to multiply it by 2. So it's the number of atoms of one element times the molar mass from the periodic table, and then divided by the total molar mass. So now I'm going to add up both the hydrogens and both the oxygens together. So oxygen is about 16 times 2 is 32, plus 2 more from the hydrogen is 34. And then multiplying that by 100. And this would be for hydrogen. And then you would do the same thing. You could do it for oxygen. So oxygen is about 16, like I said, times 2 is 32, divided by the total times 100. And you can see that the percentage of oxygen is going to be way bigger than the percentage of hydrogen. And that's how you do percent composition. And like I said, sometimes they call it percent by mass. All right, our next calculation is about empirical formulas. So first of all, you need to know that empirical formula is talking about the simplest ratio of ions or elements in the compound. So for ionic compounds, we always simplify those ratios, and so they're always going to be the simplest form. They're always going to be empirical. But covalent compounds will not necessarily be empirical formulas. So for example, if you go back to biology, sugar is C6H12O6, and that is not an empirical formula, but it's the real formula for sugar. You have to have all of those to be sugar. So we're going to first talk about how to do empirical formulas, and then I'll show you how to do those molecular formulas. So we have 3 steps here. Most of the time you're going to be given percentages. Sometimes you'll be given grams. Either one is fine. Because if you're given percentages, you can go ahead and assume 100 grams. And so now instead of percents, you just have grams because you chose 100 as your amount. So go ahead and assume grams. And then the first step is to convert each one into moles. So for right here, we have 43.64. And this is for phosphorus. And then if you look up phosphorus on the periodic table, it's about 31. I'm just going to round it, about 31 grams per 1 mole. Then we're going to do the same thing for oxygen. We have 56.36 grams, and we're going to turn it into moles. Oxygen is about 16. Now be careful here. A lot of times people will multiply that 16 by 2 and say, oh, but oxygen is one of those Hofbrinkel elements. It's diatomic. And that's true. It is O2 when it's by itself. But the whole point of this problem is to figure out how it's bonded to phosphorus. And so since it's bonded to something, in this case, it's not diatomic. So this gives us 1.409 moles of P. And this gives us 3.5, try to squeeze it in, 23 moles of O. All right, we can't use these as subscripts because scientists don't want to see these long, messy decimals as a subscript. So we need to get this into a better ratio that is a whole number ratio. And the easiest way to do that is to divide both of them by the smallest. So we're going to divide both of these by 1.409. Because that will at least turn one of them into 1. So 1.409 divided by 1.409 gives us 1. Separate this so we don't get confused. And then 3.523 divided by 1.409 gives us 2.5. And now the problem here is a lot of people will try to round that, but because we're trying to find ratios, 2.5 is not close enough to round. If it was 2.99, yeah, you could round that to 3. Or if it was 1.001, you can round that down to 1. But something that's in the middle, like 0.5, is not close enough to round. So the last thing you need to do is that last step, is to find an integer to multiply everything by to make them whole. So you don't even have to memorize them. It's not bad if you want to. There's only 3 that you'll probably see. 0.5 you can multiply by 2, 0.33 you can multiply by 3, and 0.25 you multiply by 4. It's just a fraction. So 0.5 is a half, 0.33 is a third, and 0.25 is a fourth. You probably won't see anything besides those, but if you did, just use trial and error. So if 2, 3, and 4 don't work, try 5 and then try 6. And eventually you'll be able to find a number that you can multiply everything by to make it whole. So in this case, 2 works, so we're going to multiply that 2.5 by 2 to get 5 for oxygen. However, be careful here because you also have to multiply the other one by 2 as well. And that's a common mistake I see is people forget to multiply the other number by that integer. So now we have our 2 subscripts, and we can say that our final answer is P2O5. And that is our empirical formula. All right, let's go through the steps for molecular. This is our last type of calculation for today. So first of all, molecular formula is the actual formula. So going back to sugar, if you look at that formula right there, C6H12O6, that's the real actual molecular formula for sugar. It's not empirical because it's not simplified, but it is the real formula. So to find this, you need 2 pieces of information. You need the empirical formula. If you don't have it, that might be the first thing you have to calculate. So you might have to go through those steps that I just showed you to get the empirical formula. And you also need to know the known molecular mass, which will be given to you in the question. So the first thing you're going to do is to find the mass of the empirical. So here's our empirical formula. We're going to add up the mass of this. So 2 times 31 and 5 times 16 should give you, I got close to 142. So we'll say 141.9. That's just adding up 2 phosphoruses and 5 oxygens. Then what you're going to do is take the real mass. What you're trying to do is see how many times bigger the real one is compared to the smaller one. So we're going to take the bigger number and put it over the smaller number to see how many times bigger it is. And this gives us 5. And at this point, you should get a number really close to a whole number. If you don't, you probably did something wrong. So it might be like 4.999 or something, but it should be really close to a whole number. That tells you how many times bigger the real formula is. So now you're going to multiply all of your subscripts by that number. So here's our empirical. We're going to multiply that by 5. So we end up with P10O25. That is the molecular formula. And then be careful. A lot of people get that and then they look at it and they think, oh, wait, I can simplify that. And then they simplify it back to the empirical. So make sure you're not doing that. If they're asking you for the molecular formula, it probably won't be simplified. It'll be something that could be simplified, but you're not going to. And that's it for today, but you do need to practice some of these just to get the hang of going through those steps. So make sure you practice these problems for today.